Okay, now let's recap what we have done so far. Uh, remember, this is the first stage. We are developing the control limits for a production process. So we need to collect repeated samples, 20, 25, 30 samples, each of the size about 4 or 5 or 6, okay, depending upon the need of the production process. And from each sample, you have to compute the mean X bar and the range R. Okay. But before that, okay, one of the prerequisites before even collecting these samples, you have to make sure that you investigate the production process and you made sure to the best of your abilities that the process is operating according to specifications and there are no assignable cost variability in the production process. Okay. You need to make sure that the production process has only natural variability. And then you start collecting the samples. You collect the X bars and the R's and then find X double bar and R bar and then develop your control limits from A sub 2, D sub 3 and D sub 4 factors. So once you have done that, then you have to verify. See, initially, remember, before you start taking the samples, you have to make sure that the production process is operating properly and there are no assignable cost variability, right? So you have to verify that by plotting these control limits and the X bars that we got from each sample and see whether it is consistent with a process that is you assume to be uh, having only natural variability. And so you have to chart. So here is a chart of X bar and R chart. So it has 4 lines. Each of them will have 4 lines. So you have the lower control limit and the upper control limit. Okay. And then at the middle, you have the X double bar. So this is the central tendency and this is the amount of variability that you will normally see in a 3 standard deviation interval. 99.7% of the variability should fall within these 2 limits. Okay, same here. Okay, so then you plot the 4th line is the actual X bar value. For X bar chart, the actual X bars are plotted. For R chart, the R values are plotted. And then you examine these. Okay, and there are what are called run tests that you apply, and each of the run tests you must pass each of the run tests for the process to be deemed in control and that these process charts are good to go. So for these process charts to be good to go in the sense that now you can take and apply it to a production process. When you apply it to the production process, you will take samples at regular intervals but not as frequently as you did in stage 1. So if you, at the time of developing the chart limits, you may take samples every 15 minutes. Whereas when you apply the approved charts, you may take samples every hour or every 2 hours or even once shift. Okay, so now you have to verify that the chart is good to go, and for that you have what are called run tests. These run tests are patterns that you should look for. So here is an example of a fairly random normal behavior. If you see something like this, then the chart is good to go. But if you have even one observation that falls outside the upper or the lower control limits, okay, so then that means that what we assume to be just normal operation of the production process is actually not being borne out with the samples that we have taken. So there is some problem. The chart limits that we have developed cannot be applied for production. So you have to go back to the drawing board and see what the problem is and fix that. Not only this kind of pattern is an indication of having to go back to the drawing board, there are a few more. So here in this pattern, so you have 2 consecutive X bars, both falling very close to the upper limit. Even though none of them is outside the limit, but the 2 are so close that causes suspicion. Here it is 2 which are very close to the lower limit. Okay, that again is a problem. So if that happens, two consecutive X bars falling very close to either the upper or the lower limits, that's a no-go. Then we have what are called run of 5. Okay, run of 5 here means 5 sample means or 5 R's if it is an R chart. Okay, falling in one side of the middle line. See here, the X bars are going up and down, but these 5 consecutive X bars are all up in the upper half. And this is the same. This is example when 5 of them are in the lower half. If 5 consecutive X bars are on the same side of the middle line, then that is again a problem. The chart limits that we have developed cannot be used in production. Yeah. And here's a variation of the run of 5. So that is, even though these X bars do not fall on exclusively one side of the middle line, okay, there is a general upward swing. Okay, the trend is either same direction, 5 of them going in the same direction. Okay, that is a problem as well. And then erratic behavior is also a problem. So it goes down, goes up, goes down, and goes up. Keeps going up and down, up and down. Is erratic behavior is not just purely random behavior. So these are there are 5 of them. Okay, outside the limits is 1, right? And then 2 close to the limits. That's the second. Okay, run of 5 is third. Okay, and trend of 5. Okay, that's the fourth, and erratic behavior is the fifth. If any one of these is true, then the chart limits that we have developed cannot be used in regular production.